The quest to answer one of humanity's oldest and deepest questions, are we alone in the universe, has taken a dramatic new turn on Mars. Over decades, Mars has captivated scientists and stargazers alike. Its red, dusty surface hiding clues to a past that may not have been so barren. Recent findings from NASA's Perseverance rover, announced in September 2025, have offered the strongest hints yet that ancient microbial life may once have thrived on the red planet. These discoveries build upon years of exploration and analysis, weaving together a story that is equal parts science, perseverance, and wonder. At the heart of these revelations lies the Jezero Crater, a site chosen for its geological promise and history as a potential ancient lakebed. Perseverance, NASA's flagship rover, has been exploring this landscape since its landing in 2021. In its relentless search for signs of life, Perseverance collected a rock sample known as Sapphire Canyon from the Bright Angel Formation within the crater. It was here that scientists made a breakthrough that sent ripples through the scientific community. The Sapphire Canyon sample is remarkable for several reasons. First, it contains two key minerals, vivianite and greigite. On Earth, these minerals aren't just geological curiosities, they're often found in environments shaped by microbial life. Vivianite, a blue-green phosphate mineral, and greigite, an iron sulfide, are typically associated with regions where microbes drive chemical reactions, especially those involving changes in oxidation. These minerals suggest that, at least at one point in its history, Mars may have had the right conditions for life to flourish. Adding to the intrigue are distinctive markings within the rock, referred to as leopard spots. These patterns are believed to be the result of redox reactions, chemical processes involving the transfer of electrons. On Earth, redox reactions are closely linked to the way living organisms process energy, and they leave behind characteristic traces in rocks and minerals. The presence of these markings on Mars hints at the tantalizing possibility that similar microbial processes once took place in the ancient Martian environment. But the story doesn't end there. Earlier in 2025, NASA's Curiosity rover made another major discovery: the longest carbon chains ever detected on Mars, preserved within a 3.7 billion-year-old rock sample. Carbon chains are the backbone of organic molecules, which are in turn the foundation of life as we know it. The existence of these molecules suggests that Mars was not always the cold, lifeless expanse we see today. Instead, it may have once hosted a far more dynamic and potentially habitable environment. Yet, as exciting as these discoveries are, scientists remain cautious. Organic molecules can arise from non-biological processes, especially on a planet as geologically active as Mars. The challenge is to distinguish between what could have been formed by purely chemical means and what requires the intervention of living organisms. To do this, researchers need to conduct more sophisticated analyses, tests and experiments that are currently beyond the capabilities of rovers operating millions of miles from Earth. That's where the Mars Sample Return mission comes in. This ambitious project, a collaboration between NASA and the European Space Agency, ESA, aims to bring Martian rocks and soil back to Earth for detailed study. Scientists hope that by examining these samples with the full arsenal of modern laboratory techniques, they'll be able to answer definitively whether Mars ever supported life. However, the mission has faced significant hurdles, including delays and budget overruns. As of September 2025, the mission is on hold, with no clear timeline for when, or even if, the samples will make their way home. Despite these challenges, the scientific community is abuzz with excitement. The discoveries from Perseverance and Curiosity have rekindled interest in Mars as a living world, rather than a dead planet. They suggest that billions of years ago, Mars may have had a stable climate, liquid water, and the chemical building blocks necessary for life. If confirmed, these findings would not only transform our understanding of the red planet, but also reshape the way we think about life in the universe. The significance of these discoveries cannot be overstated. On Earth, vivianite and greigite are often found in habitats where microbes thrive, such as wetlands, lake sediments, and hydrothermal vents. Their presence on Mars raises profound questions. Did Martian microbes once inhabit ancient lakes and rivers? Did they leave behind molecular fingerprints that have survived for billions of years, waiting to be uncovered by a curious rover? The leopard spot markings, suggestive of redox reaction, add another layer of evidence, pointing to a time when Mars was chemically active in ways that could support life. The carbon chains discovered by Curiosity further bolster the case for ancient habitability. Long, complex carbon molecules don't just form out of nowhere. They require a rich and varied chemistry, the kind found in environments with water, energy sources, and time. While it remains possible that these molecules were created through non-biological means, their mere existence on Mars raises the possibility that life, however simple, might once have gained a foothold there. The pursuit of Martian life is not just a scientific endeavor. It's a journey that stirs the imagination. It challenges us to look beyond our own planet and contemplate our place in a vast, mysterious cosmos. The Perseverance rover, with its tireless exploration and cutting-edge instruments, embodies this spirit of discovery. Every rock sample it collects, every image it transmits, brings us a step closer to answering the question that has echoed across centuries: are we alone? As researchers prepare for the next phase of exploration, they remain focused on the need for rigorous analysis. The samples collected so far will be subjected to the most advanced techniques available, whether on Mars or, hopefully someday, back on Earth. The Mars sample return mission, despite its current hiatus, represents the best hope for unraveling the secrets hidden within Martian rocks. When those samples finally arrive, they could settle the debate once and for all, providing either definitive proof of ancient life or new mysteries to ponder. In the meantime, every new discovery serves as a reminder of how much we still have to learn. Mars, once thought to be a dead world, continues to surprise us with its complexity and its potential. The search for life on Mars is far from over, and with each passing year, the evidence grows stronger. Whether it's the minerals that whisper of ancient microbes, the carbon chains that hint at organic chemistry, or the patterns etched by redox reactions, Mars is slowly revealing its secrets. As we stand on the brink of a new era in planetary science, one thing is clear: the question of life on Mars is no longer a distant dream. It's a tangible possibility, supported by the latest discoveries and driven by the relentless curiosity of scientists and explorers. The journey is long, the challenges are many, but the rewards, the chance to answer one of humanity's most profound questions, are truly priceless.